Hello, how are you? How was your vacation? By the way, I'm Mr. Benji and I will be your math teacher for this term. So for the very first lesson online class that we're going to discuss in mathematics, we are going to learn about numbers. We are going to learn about how they are arranged in a certain sequence. Are you ready? If you are, let's begin. So the very first topic that we are going to learn is about number patterns. And there are so many words that we are going to discuss and use in this topic. So what is the sequence? What do you mean by the word sequence? Now look at these numbers. We have 2, 4, 6, 8, and 10. They make up a sequence. So we have here commas to separate them and three dots to signify, to tell us that it is continuing. It's a sequence of even numbers. So they are all even numbers. So 2 is an even number, 4 is an even, 6, 8, and 10. They are all even numbers. 2, 4, 6, 8, and 10 are some of the terms in the sequence. So they are terms. So 2 is a term, 4 is a term, 6 is a term, 8 is a term, 10 is a term also. So adding 2 every time is the pattern used in this sequence. So when we talk about number pattern, the number pattern or the pattern of the sequence of number is adding 2 every time. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 it's 10, plus 2 it's 12, and so on. So let's learn also some simple number patterns. These are number patterns that we usually see, and we can give examples under these patterns easily. They are very common and they are very easy to remember. So we do have a pattern of even numbers. So 2, 4, 6, 8, 10 are even numbers. So we call them a sequence of even numbers. Do you have also a sequence of odd numbers? So this time we will use only odd numbers. So 1 is an odd number, 3 is an odd, 5 is an odd, 7 is an odd, 9 is an odd. So we also have square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. We also have cube numbers. 1 cube is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So they are called the sequence of cube numbers. We also have triangular numbers. So what is the sequence of triangular numbers? Try to notice these dots. Okay, to make a triangle, for us to make a triangle using dots, so we need 3, here we need 6, here we need 10, here we need 15. So we have 1, 3, 6, 10, 15, and the next one should be 21 because we are going to add one layer here, which is 6 plus 6. So the next answer is 21. So 1, 3, 6, 10, 15 is a sequence of triangular numbers. We have also Fibonacci sequence. What is a Fibonacci sequence? All you have to look up here is to look at the sum of the two numbers before a number. Like here, we don't have a number here, so that means to say we can use a 0. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. So we know that the next number is 21. So 13 plus 21, and so on. So that is Fibonacci sequence. So these are simple number patterns. So these are very, very easy to remember sequences of numbers. So now we are going to solve the number pattern of different numbers without using those number patterns or easy to remember sequence of numbers. Now here we will find the number pattern or the way or the formula that we will use to find a certain number that is being asked for us to find. For example, here, describe each of the following number sequences. Like here, list the fifth term. You have to know what is the fifth term of each sequence. You have 76, 78, 80, 82. So here, so the solution is this. So from 76 to 78, that's plus 2. 78 to 80, it's plus 2. 80 to 82, it's plus 2 again. So therefore, if we are going to add plus 2, or we are going to add 2 to 82, the answer is 84. So we know that the fifth term is 84. So to describe the number sequence or the sequence of these numbers, so it is a sequence of even numbers, and the fifth term is 84, as we have got here. So for B, to find it, we have to compare it to cube. So 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. So we know that the next number should be 7 cubed. And to get the value of 7 cubed, we have to multiply it 3 times, which is 343. 7 times 7, 49. Times 7, it's 343. So the answer should be 343. So we can describe it as a sequence of cube numbers, and the fifth term is 343. How do we recognize the number pattern of a sequence of numbers? How do we find the formula? So we're going to learn that one today. So here I labeled it T sub 1. T sub 1 means term. We know that this, and this are terms in a sequence of numbers. So this one is T1, T sub 1, or our term 1, T sub 2, or our term 2, T sub 3 as our term 3, and T sub 4 as our term 4, T sub 5 as our term 5. So there's a pattern here being formed. So 3 going to 7 is plus 4, 7 going to 11, it's plus 4, 11 going to 15, it's plus 4, and 15 going to 19, it's plus 4. So what is the 101st term in the sequence? So maybe you might think, okay, I'm just going to list it down. I'm going to add 4 here and add 4 again. But the thing is, this is 101st term. It means to say you are going to spend a lot of time solving it. But there is a shorter way of doing it, of finding it. All we have to do is to find a formula, perfect formula to solve it, or the number pattern that we should use to find this term. So how do we do it? So let's list it down first. So first term, or T sub 1, is equal to 3. Second term, or T sub 2, it's equal to T sub 1 plus 4. What is T sub 1 is 3, plus 4, it's 7. So I just did it that way because there's a purpose of doing that one. And we will explain that one later. So here we have 3 plus 1 times 4. So why did I do that? T sub 1 is 3 plus here 4 means to say there's only one 4, so 1 times. So third term, or T sub 3 equals T sub 2 plus 4. Our T sub 2 is 3 plus 1 times 4. So we will add 4 to that. Because we do have 2 4s already, so therefore we can say 3 plus 2 times 4. For the fourth term, we can put T sub 4 equals T sub 3 plus 4. So for that, we add 3 plus 4 plus 4 plus 4. So we can simplify that one. 3 plus 3 times 4 because we use 3/4 here. Look at that. To get this number, we have to use the term number, which is 2. Then we just have to subtract 1. So 2 minus 1 is 1. So the next one, we have 3. 3 minus 1 is 2. Next one, it's this one. It's this one. 4. 4 minus 1 is 3. So n term. So we have n. We have the pattern already here. So how do we solve it? How do we find n? So here, as you can see, we have n minus 1 because we don't know the number yet for n. So we just have to subtract 1 to it because it's the same thing happened here. So the n is the term number, which is n. Just subtract 1, then multiply by 4, then add to 3. So the number pattern for the sequence is T sub n equals 3 plus n minus 1 times 4. So actually, you can still simplify this one, but I will teach you that one later. Let's leave it that way. So now here, we are going to use our formula or our number pattern to find this term, the 101st term. To get it, T sub n equals 3 plus n minus 1 times 4. Substitute it. T sub 101 equals 3 plus, for n, that is 101, minus 1 times 4. So we know that 101 minus 1 is 100, times 4, that's 400. So therefore, this is 3 plus 100 times 4. So 3 plus 400, the answer is T sub 101 equals 403. So therefore, the 101st term is 403. So let's have more examples. For example, we do have these numbers. The term 1 is 970, term 2 is 940, term 3 is 910, term 4 is 880, and term 5 is 850. So the difference between them, between two numbers, is 30. This is minus 30, minus 30, minus 30, minus 30. What is the 21st term in the sequence? So it's a lot of work. We're going to list it down manually. So we will find the number pattern, the formula to use to find this term. So first term again, T sub 1 equals 970. Second term, T sub 2 equals T1 or T sub 1 minus 30. So that's 970 minus 1 times 30 because we just subtracted 130 here, 130 here. So the third term, we have T sub 3 equals T sub 2 as T sub 2 minus 30, which is equal to 970 minus 30 minus 30. So we can simplify that one. 970 minus 2 times 30. So what's the n term? So T sub n equals 970 minus n minus 1 times 30. So here we have n minus 1 times 30. Remember, where did we get this n minus 1? So here, minus 1, minus 1. This one should be minus 1 also. So we will simplify this one. We will simplify this one. This is not the n yet. So we will simplify it to make it look nice or nicer. So let's do it. Let's simplify. So how do we do it? So we have to distribute it. So of course we have to multiply n by 30 first. So that is 30n. Then we have to multiply 30 by 1. That is minus 30. So because the sign in between is minus. So therefore this one should be minus also. Now the thing is, this minus sign should be distributed also to the numbers inside the parentheses. So 970. So this is minus. We know this is positive, right? So therefore positive times negative, that will be negative. So or minus 30n. So this one thing is, this one is minus 30, But then the thing is this one minus and this one is minus. So minus minus, that is plus 30. So to simplify it, this one is 970 plus 30. The answer is 1000. Then we will just have to write this minus 30n. So the number pattern for the sequence is T7 equals 100 minus 30n. So by using that, we can finally find the 21st term, wherein T sub 21 equals 100 minus 30 times 21. Yes, this one is 30n, so we just have to substitute that, 21 here, 21 here. So T sub 21 equals 1000 minus 30 times 21 is 630. So when you subtract that one from here, so the answer is 370. So therefore, the 21st term is 370. So by using this formula alone, we don't have to write down all the numbers in the sequence. So we can easily find the 21st term. Let's have more examples. So we have here the T sub 1, we have 5, T sub 2, we have 10, T sub 3, we have 20, T sub 4, we have 40, and T sub 5, we have 80. So to go to 10, we have to multiply 5 by 2. Same thing here, times 2 again, times 2 again, and another times 2. So how do we find the number pattern? And what is the 11th term in the sequence? So let's solve it. Same thing we do. First term T sub 1 equals 5. Second term T sub 2 equals T sub 1 times 2. And that is equal to 5 times 2 raised to 1. So we know that 2 exponent 1, or 2 to the power of 1, is the same as 2. So most of the time we don't need to write the exponent. But here, let's just show it. So third term, we can use T sub 3 equals T sub 2 times 2. What is T sub 2? T sub 2 is 5 times 2 raised to 1. So this one is 5 times 2 times 2, where we can write it simply by saying 5 times 2 raised to 2. So the fourth term is T sub 4 equals T sub 3 times 2 equals T sub 3 is 5 times 2 times 2, then times 2 again. So we can write it simply by writing this number is 5 times 2 raised to 3, because we do have 1, 2, 3, 3 2's here. Now look at this one, the relationship here. So the exponent here, we got this exponent by doing this. The term number, which is 2, minus 1. So 2 minus 1 is 1. So same thing here. For the n term, therefore we can have this. So here, T sub n equals 5 times 2. So we do have here n minus 1. So we just have to subtract to the exponent number. So in this case, this is n. So the number pattern for the sequence is T sub n equals 5 times 2 raised to n minus 1. So T sub n equals 5 times 2 raised to n minus 1. So we have to find the 11th term, so we just have to substitute it. T sub 11 equals 5 times 2 raised to 11 minus 1. So it is T sub 11 equals 5 times 2 raised to 10, because 11 minus 1 is 10. So here T sub 11 equals 5 times 2 raised to 10 is 1024. So when we multiply them, the answer is 5,120. So the 11th term in the sequence is 5,120. So we're done with that. So we're ready to solve this exercise. So this is the test yourself part of your book, test yourself 1.1. So let's read first numbers here. So for number 1, describe each of the number sequences. Please the 10th term of each number sequence. So we do have for A, we have 100, 102, 104, 106, 108, for P, 144, 169, 196, 225, 256. For C, we have 79, 81, 83, 85, 87, 89. For D, we have 1, 8, 27, 64, 125. For E, we have 3, 6, 10, 15, and 21. For F, we have 1, 1, 2, 3, 5, 8. So how do we solve it? How do we answer it? So here we have the following. So we have 100, 102, 104, 106, 108. So that is plus 2, plus 2, plus 2, plus 2. So how do we know it? This next term. So we have to add plus 2. We have to add 2 again, 2 again, 2 again, 2 again. And it's even numbers, so the 10th term is 84. So by listing down those numbers that we got, 84. So the 10th term is 84. And this is a sequence of even numbers. So how do we find number 2? So find the number pattern for each number sequence, list the 25th term of each number sequence. So we have A, we have 10, 9.75, 9.5, 9.25, 9. For B, we have 7, 15, 23, 31, 39. For C, we have 3, 6, 9, 12, 15. For D, we have 7, 9, 11, 13, 15, and 17. For E, we have 6, 18, 54, 162, and 486. So how do we find the answer for this? So we will do the same thing here. We will list them first. The differences between them, that is minus 0.25, minus 0.25, minus 0.25, and again, minus 0.25. But then the thing is, we have to list the 25th term. So if we're going to do it manually like we did in the first one, so it's going to be very, very long. So we're not going to do that one. We will find the number pattern for this by finding the formula that we can use. So first term, t sub 1 equals 10, t sub 2 equals t sub 1 minus 0.25, wherein we can write it as 10 minus 1 times 0.25. So the third term, we have t sub 3 equals t sub 2 minus 0.25. So in this case, we have 10 minus 0.25 minus 0.25, wherein we can write it as 10 minus 2 times 0.25. So to find the end term, we have to establish the relationship between these numbers that we use here. 1, 2, to get these numbers, we know that we get the term number, which is 2, minus 1 equals 1. Same thing here, 3, the term number 3 minus 1, that is 2. So for n term, the term number is n. Therefore, t sub n equals 10 minus n minus 1 times 0.25. So we can simplify that one. T sub n equals 10 minus 0.25 n minus 0.25. So what we did here, we just distributed it, multiply n by 0.25. Same thing with 1. And copy the sign in between, which is minus. Then we will simplify it, multiply this sign to those two numbers inside. So t sub n equals 10 minus 0.25n plus, why it became plus? Because this one is minus, times minus, that is plus 0.25. And the answer is equals, this is equal to 10.25 minus 0.25. So where did we get the 10.25? 10 plus 0.25. So to find the 25th term, so we just have to substitute it. So t sub 25 equals 10 minus 10.25 minus 0.25 n. To substitute that one here, so 0.25 times 25, the answer is 6.25. So 10.25 minus 6.25 equals 4. So the 25th term of the sequence of number is 4. And okay, so that's the end. That's the end of our lesson. So thank you so much for listening. Hope you learned something from this. And we'll see you again next time in our next online class. Thank you so much. And goodbye and God bless. Thank you.